OK, so ladies and gentlemen, what we've kind of discussed is when we looked at different graphs, we know that each little graph, basically, as we zoom in, we can find that there is like a line that makes up at any individual point. Doesn't matter what the point is, we can always find a local line, right? You guys agree with me? OK? So kind of going into, if we know we want to find a line, then we know that based on a line, if we have kind of like 2 points, we can create the slope. Correct? So here's given 2 points. Now, here is a axis. Instead of a y-axis, we have an x-axis and an f of x axis. All right? So what I'm going to do is I'm going to give you 2 arbitrary points. We have a, and then we have x. All right? Now, the output would be f of a. And whatever x is, the output over there would be f of x. Correct? And in the same respect, we're going to look at this a different way. Let's just say here's x, and then the output value would be f of x. And let's say I add some arbitrary number h to get to a new point, right? That could be 2, it could be 1, whatever it may be. But I get to a new point. Well, that new point is going to be called x plus h, whatever we added. And then the output value is going to be f of x plus h. Would you guys agree? OK, so between these 2 points, we're going to create a secant line. Basically, a line that we could find the slope of. Would you guys agree? We can find the slope of those 2 points. So using the slope formula, we would basically say f of x minus f of a all over x minus a. Would you guys agree that would be the slope of that secant line? Right? And we could find the slope. So what, if we knew what a and x were, then we could find actually a slope like we did in our warm-up. Correct? On contrary, same thing over here. This one's going to look just a little bit more confusing, but it's not as bad. This one would be f of x plus h minus f of x all over x minus, I'm sorry, x plus h minus x. Would you guys agree with me that I'm not doing anything crazy yet? Right? This is all stuff that we know. It just looks very confusing with a lot of like the notation and arbitrary variables that we have like no idea what their values are. We'd like to have, we're OK with them being concrete values, right? But here we're just saying these are variables that we don't know. Now, when we looked into Desmos, we zoomed in. This line doesn't really give us the exact line at a given point, right? Let's say we wanted to figure out what this slope was right at the point A. What if we want to find the slope right at A or this point right here? You guys agree with me that the secant line doesn't really do its best job, does it? Like that slope and this slope are not the same. Would you guys agree? Would everybody agree? So these 2 slopes, this would be what we call a tangent line, right? It only touches the graph once. So these are your tangent lines. Here's your secant line, crosses the graph twice. You guys agree the secant and the tangent line are not the same. So what our goal, or what we're going to want to try to do to find local linearity, is to get that secant line closer and closer to that tangent line. So what would happen then if I started taking x and started taking x closer and closer to a? Let's say I move x to right here. Does the secant line look like it's getting a better representation of the tangent line? Is the slope decreasing so it's closer to the tangent line? Yes? Does everybody see? Ethan, you see? Yes? Let's look over here. Let's make h smaller. Let's say h over here was 5. Now let's make h 2. Whatever. So it's getting smaller. As I create my new secant line, do you guys see that the slope is decreasing, so it's getting closer and closer to this tangent? Right? So in a perfect world, would you guys agree that if h was actually 0, like if we approached 0, then that would give us our tangent line? Right? I mean, as I get closer and closer, so here's h. As I get closer and closer to what x is, you guys agree with me that that slope's going to be a better and better representation. Does that make sense? In the same respect over here, as x gets closer and closer, it's going to give us a better and better, closer slope to that tangent line. Yes? So going off of your knowledge, when we talk about approaching, we can use the notation of, we just took a test on it, so limits, right? So in reality, let's look at this one first. In reality, what value do we want h to be, or what value do we want h to approach? What value do we want h to be? Do we want h to be 5, 2, 1, 1/2, 1/4? Yeah, but what do we? Yeah, but h represents the distance from x. So what do we want that distance to be? 0. We don't want any distance, right? It's at 5, it's at 2, it's at 1. We want h to approach 0. So I'll write the limit as x approaches 0. Now notice here, x and negative x, those go to 0, right? So therefore, we'll have f of x plus h minus f of x all over h. OK? You're going to want to write that down. We'll talk more about that in a second. Over here, here is kind of what somebody was saying. Here, we're not really talking about the distance. We're talking about 2 points. X is to a. So as we're going this way, what do we want x to approach? You're saying it. Well, 0 would be over here. We don't want x to approach 0. What do we want x to approach? A, right? So my limit is going to be x approaching a of f of x minus f of a all over x minus a.